Okay, let's dive into this. Picture a giant, rugged asteroid just silently floating there, glowing under the harsh sunlight of deep space. It sounds like pure sci-fi, right? Well, actually, it's the subject of some really intense real-world study today. Welcome to today's Explainer, where we're going to break down the absolutely fascinating and literally astronomical potential of asteroid mining. Seriously, what if the next gold rush wasn't on Earth, but out in space? I mean, think about it. For centuries, we've scoured our own planet for valuable resources, drilling deeper and deeper into the bedrock. But today, the research is asking us to shift our perspective upward. It suggests that the ultimate frontier for wealth and raw materials isn't beneath our feet anymore. No, it's actually orbiting right above our heads. Which brings us to this idea of a cosmic treasure trove. You see, researchers aren't just looking through telescopes and admiring these rocks as, astronomical curiosities anymore. Not at all. They are studying them with a very specific and highly lucrative goal in mind. And this brilliantly illustrates the incredible prize scientists believe is locked inside these floating space rocks. When we break down what's actually inside them, particularly the M-type or metallic asteroids, we're talking about massive, incredibly concentrated deposits. You've got foundational metals like iron and nickel making up roughly 50 and 40% of the mass, respectively. But it's that final 10% slice that completely changes the math. We're talking precious metals, platinum, gold, palladium. To put that into perspective, just a single stadium-sized asteroid could contain tens of billions of dollars worth of these rare elements. Tens of billions! The ability to mine these high-value materials directly from space, completely bypassing all the environmental and geological limits we have here on Earth, is exactly what's driving the economics of this whole field. Of course, actually knowing that treasure is out there, well, that's really only half the battle. Extracting resources from an asteroid in a zero-gravity vacuum, that demands a playbook of advanced robotics and precision engineering that pushes the absolute limits of human achievement. We're talking highly advanced technology here. Let's see how this all builds together into a hypothetical robotic extraction process. It relies on this beautifully synchronized dance between machines and human oversight. Step 1. A spacecraft navigates the vast emptiness of the void to match an asteroid's incredible velocity, right? It has to land gently on this rugged, spinning surface. Once it's secured, step 2, it deploys highly specialized autonomous robots to actually begin drilling and collecting material. But here's where it gets really smart for step 3. Onboard AI instantly analyzes the material's chemical signature and value in real time. This is absolutely crucial because it eliminates the need to haul completely worthless rock all the way back home. And finally, step 4. Meanwhile, human engineers sit at mission control back on Earth, carefully monitoring the whole automated mission from afar. They're dealing with massive communication delays, which is exactly why that on-site AI has to make those split-second operational decisions on its own. Now, we do need to pause for a second and ground ourselves. As the source explicitly states, asteroid mining remains a major engineering challenge. It is so important that we don't just skip over the immense friction between our sci-fi ambitions and our actual current technological limits. I mean, trying to set up a fully autonomous facility on a giant rock hurtling through the solar system at tens of thousands of miles per hour? Yeah, that is incredibly difficult. Now, what's really interesting about this comparison is how sharply it contrasts the two monumental logistical hurdles currently blocking our path to the stars. On one side, you have extreme distances. Asteroids aren't just sitting in our backyard. The journey alone involves incredibly complex orbital mechanics. It can take months or even years just to arrive at the destination. And then, on the other side, you have extreme expense. Escaping Earth's gravity well costs an absolute fortune. We are talking thousands of dollars for a single pound of payload. When you compound those vast distances with the immense financial cost required just to get the heavy drilling machinery and all that return fuel up into orbit, you see exactly why this remains such a daunting challenge. The return on investment has to absolutely eclipse those astronomical upfront costs for this to ever work. But let's guide our focus back toward the tantalizing payoff here. Picture this scene. The robotic mission is a total success, a futuristic spacecraft. Its cargo holds completely filled with refined iron, nickel, and precious metals, slowly pushes off the asteroid. As it turns its trajectory homeward, the Earth appears in the far distance, waiting for these new resources. You see, this isn't just about bringing back shiny rocks to get rich. This is really about fueling our future. So, the crucial point is the ultimate game changing impact this technology would have if researchers can actually overcome those engineering challenges and massive expenses. First off, it could support future space missions by allowing us to build and fuel ships out in space using local materials. By mining water ice found on some of these asteroids and splitting it into hydrogen and oxygen for rocket fuel, we'd essentially be creating interplanetary gas stations. That way, we aren't dragging all that heavy fuel all the way up from Earth. Second, it fundamentally changes how we obtain certain resources, potentially saving our own planet's finite reserves. Moving heavy extraction industries off-world and sourcing our core building blocks directly from the void, that represents a total paradigm shift for human civilization. Which leaves us with this final, incredibly thought-provoking question to ponder today. Knowing the immense value floating out there, understanding the brilliant robotic technology required to get it, and seeing the massive engineering challenges standing in the way, would you travel to space to mine an asteroid? It is literally the ultimate frontier job. I highly encourage you to follow Future Tech Insider for more amazing future tech stories just like this one as we continue to track humanity's progress toward the stars. Thanks so much for exploring this cosmic gold rush with me today.